All right, here for chapter 13, worksheet B, just doing problem number 2 for this one. So here we go. So we're given a graph here, and so we're kind of told up here what that graph represents. The D is for depth. Notice that's the Y coordinate, so there's our Y axis for depth. It talks about meters of water in the harbor T hours after midnight. So always really important that you notice the details like that. That's always really important to know what's going on there. If you look at the equation that we're given, so again, they're telling us that the domain T is in hours, and so you can see based on this, it represents a 24-hour period, basically from midnight to midnight. So based on what that's saying up there, and we know the result, the Y coordinate, the value would be D, the depth. So given a cosine function for this one, so it gives us a few more details. So P and Q are positive constants in the following graph. So this point is a minimum, which is already labeled on the graph, and we also have a maximum, which is also labeled on the graph. So a couple things we should be able to knock out pretty quick on this one in part A. Find the value of Q. If you look up right here, whatever value is being multiplied times the trig function is always what we used to call like the A value, but it's always in relation to the amplitude of the graph. And so if you look at this graph, you can see in terms of the Y coordinates, it goes as high as 17.8, goes as low as 9.4, which means we need to kind of identify the center or the midline of that graph. And so if I just add those two together and divide by 2, that would tell me the center of this graph somewhere over here on the Y axis. So by finding the average of those two Y values, if I add those up and divide by 2, it helps me to see that 13.6 is the midline or the center of this graph right here. So that line represents 13.6 on the Y. So here's where the Q value comes in. Remember that for a cosine graph, this always kind of tells you where to start. If it's positive, then you are starting that many units above the midline. If this value is negative, you would be starting that many units below the midline. In this case, you can see that we're starting above 13.6, so I know that my Q has to be positive for this one. So simply the question is how many units did we start above the center? So if I did 17.8 minus 13.6, we'd see that 4.2 is that difference. So again, that's simply the amount that we started above the center is going to give us that value. Typically, in the parent function, it's 1. You start 1 unit above the midline or 1 unit below the midline, and so we can kind of see what is being multiplied times 1 to get that value for Q. P, the guy right here sitting in place of P has to do with the vertical shift. So again, you can see that typically the cosine graph is centered at 0. And so the vertical shift always has to do with the midline of the graph. Since it's normally started at or centered at 0, well, if we are starting 13.6 units above 0, that means this graph had a vertical shift of 13.6, which is that P value right there. Find the first time in this 24-hour period when the depth of the water is 12 meters. So notice they do say the first time simply because there are multiple times where that can occur. So where is the depth at 12? So based on this, I know 12 would be somewhere about here. So notice it hits 12 here, hits 12 again right there, hits 12 again right there, hits 12 again right there. There's 4 places on that graph within a 24-hour period where we would have hit a depth of 12. And so this one simply asks when is the first time that would occur. So just to have one in there, we're going to call this red line 12, just to give you an idea. So this is where our depth was at 12. So again, you can see that would have occurred in 4 different locations or at 4 different times. So we just want to know when was the first time that occurred. Now that I have some values for P and Q, and obviously it really is important that we get those numbers right because I now need to plug those in order to do the rest of the problem. So let's plug that in. So we have our depth now. 13.6 was P. Q is at 4.2. And we got our cosine function of pi 6t So for this problem, the first time where the depth is 12, so they're giving us a value for D. So if I plugged in a 12 right there, we're just looking at this equation, which we've been solving these types of equations all chapter. So this is certainly something we could do by hand. I'll show you on the calculator as well. So we could certainly solve this by hand. If I subtract my 13.6, divide by 4.2, then take the inverse cosine of that function. So I'll do that here real quick. So I got my 12. I'm going to subtract the 13.6. I'm going to divide by 4.2. And this is, I guess I need to do this in terms of radians because I can see this is in terms of pi. So I should have my calculator in radians. So let me change that. So if I go under mode, change to radians, let me get back to my equation here. So I had this value, so if I took the inverse cosine of that, this is the value that I'm getting. So this is equal to pi over 6t. So if I wanted to get t by itself, I just multiply by the reciprocal over to the other side. So if I multiply that answer times 6 over pi, then I can get a value that way. So 3.746 something something something. So you can see that answer. One thing that really matters on this is it wants it in time. And so right now I have 3 hours and 0.746 minutes. But if I wanted to do that in terms of time, then I need to convert my decimal into minutes. And so obviously there's 60 minutes in an hour. So if I were to multiply my decimal times 60, then I can convert that into minutes. And so if let me just get rid of the 3 for a minute so I can show you that. So if I just took the decimal portion of that and multiplied it by 60, you can see that there was about 45 minutes worth of time. So my hours were 3 hours, and if I convert my decimal to minutes, you can see that would round to about 45 minutes. So 3 hours and 45 minutes after midnight, which would put it at 3:45 a.m. And so that's how we'd get that first answer. Real quick, we could do this on a calculator. If this is something within a test setting that we're able to use a calculator for, one way to solve equations like this is, let me just type in the original function first. So here's my 13.6 cosine pi over 6, call it x. So there's the original function. And so if I graph the result of 12, what I put as like the red line that you see right there, if I were to graph y equals 12, and I get that line right there, I'm going to go to my window here real quick and adjust my window. They told me right here that my window should go from 0 to 24, so I'm going to go from 0 to 24 on the x's. As far as the y values, if I just look at the graph for a minute, you can say that my lowest y value is 9.4. So I'm going to put my y minimum at 9, and my max was at 17.8, so I'm going to put my y max at 18. So I can be just a little outside of that window. So now if I hit graph, so I'm now getting the same graph on my calculator that we were seeing right here in our given diagram, exact same graph. Here comes the y equals 12. Again, you got those 4 points of intersection. So if I simply want the first point of intersection, if I hit second calc and go down to intersect, and there's 4 of them, so I need to put my cursor closest to the one that I want, which is right about there. It's going to ask me a few questions. Just keep hitting enter, 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 enter. There you go. I got this exact same value right here that I got when I solved it by hand a minute ago. I would still need to convert that into minutes so that I could write my answer in terms of time, but it's the same version of the answer, same decimal answer I got when I solved it by hand. So that's certainly fair game. We're allowed to do that in a calculator test. So that's a great tool you should know how to use for doing something like this. So part C, use the symmetry of the graph to find the next time when the depth is at 12 meters. So if I wanted to find the next time that it's at 12 meters, one way to do that would be just to go back into Calc, choose intersect. Now I'm going to put my cursor over to the next point of intersection, which is right there, approximately right there, and just hit enter, enter, enter. And right there at 8.25-ish is the next time. I would still convert that into minutes by multiplying my decimal times 60. But this is the next point of intersection. That was a really easy, quick thing to get with the use of my calculator. So that's certainly an easy way of doing it, and you can do that. The other way would be if they say to use the symmetry of the graph. What they're talking about is, obviously we can see this graph repeats itself again and again and again forever, so we can kind of use that to our advantage. You can see based on what's going on right here that at 12 hours this graph went through one full period of the graph, which means at 6 hours we're at the halfway mark. And so right here at 6 hours we're at that halfway mark. So when would it happen again? So if I just took my answer of 3:45 a.m. and kind of reflect that over to the other side, what time would that be? Well, from 6 a.m. to 3:45 a.m. you can see that would be a 2 hour and 15 minute difference right there. So if I just go 2 hours and 15 minutes after 6 o'clock, that would put me at 8:15 a.m. And so I can get my answer that way as well. So 8:15 a.m. would just be the next time that would occur. So really two pretty easy ways of getting that answer, either by the graph on the calculator or by just using the idea of symmetry. We can do that pretty easy if you just kind of understand what to look at on the graph. Last one here, so find the time intervals in the 24-hour period which the water is less than 12 meters deep. So right here you can see the red line was where it was at 12. If I want to know where it was less than 12, well, right here it was less than 12. So from 3:45 a.m. to 8:15 a.m. it was less than 12. So there's one of my intervals. So that was one interval, and then you can see it happened again in the afternoon, but in this little area right here it is also below 12. So I just need to identify those times and give another time interval like I did here. This one was made pretty easy because if these are hours after midnight and it's repeating every 12 hours, that makes it really simple because these AMs would just simply repeat in the PM. So 3:45 p.m. to 8:15 p.m. Again, that was really easy because the period cycled right at noon, right at the 12-hour mark, and so that made it pretty easy to find those next times. If you had a case where it wasn't as obvious, you could certainly do that in the calculator or by hand the exact same way we came up with this one. So you would just have to repeat a couple steps, but doing it for those points of intersection instead of for those points of intersection. But you could tackle it the exact same way. If you had it on the calculator, you could easily go back into Calc, choose intersect, and just get the points of intersection for that guy and for that guy. And you could do it that way as well. So you'd have a few options on that, but most likely they give you cases where you can use a little bit of knowledge to get your answers if you recognize the pattern of what's going on within the function.